Think about the last time your laptop got hot on your legs. Now scale that up to a building the size of a football stadium. These massive data centers are popping up in backyards from Arizona to Ireland, and they are thirsty. A single facility can easily outdrink a town of 50,000 people in a single day. To keep them from overheating, power companies are scrambling to build new plants, often passing those multi-billion-dollar costs directly onto your utility bill. We've been sold a version of AI that feels invisible, something that just exists in the air. But the reality is a heavy physical industry that's straining our power grids and drying up our reservoirs. We're looking at the secret deals and the soaring costs of the AI gold rush and asking what happens when our digital future finally runs out of room on Earth. To understand the crisis, we first have to understand what these buildings actually are. We call it the cloud, but the cloud is very much a physical place. Data centers are essentially massive warehouses filled with thousands of computer servers that store and process data. For years, they powered things we're used to, like Netflix, Spotify, or Google Docs. But the new AI data centers are a completely different beast. Training a single AI model or running billions of ChatGPT queries requires an incredible amount of processing power. A traditional server rack might use 5 to 10 kilowatts of power, but an AI server rack can need 40 to 60 kilowatts. This intensity creates a massive problem: heat. These computers get incredibly hot, and if they aren't cooled down 24/7, they'll melt. That brings us to the first major part of our crisis: water. In 2023, data centers powering AI systems in the US used about 17 billion gallons of water. By 2028, that number is expected to triple to 68 billion gallons. Why do they need it? Most of these facilities use evaporative cooling. Water is used to absorb the heat from the computers, and then it's evaporated away. In that process, about 80% of the water is simply lost to the atmosphere. The scale is hard to wrap your head around. A single large AI data center can use between 1 and 5 million gallons of water every day. In Loudoun County, Virginia, often called the Data Center Alley, these facilities used over 1 billion gallons of water in 2023 alone. In Oklahoma, Google's second largest data center used 1.1 billion gallons in a single year. The total amount of water used by AI data centers in the US in 2023 is equal to about 25,000 Olympic swimming pools. This volume could supply roughly 430,000 people for 3 years, about the population of Minneapolis. Since 2023, hundreds of new data centers have been constructed in the US alone. The problem is that many of these centers are built in dry, water-stressed regions like Arizona, because those areas have lots of solar power. This puts a massive strain on local aquifers and drinking water. While citizens are being told to take shorter showers or stop watering their lawns to save water, these giant warehouses are drawing millions of gallons a day from the same pipes. Then there is the electricity. These facilities are some of the most energy-intensive buildings in the world. In northern Indiana, a handful of planned AI data centers are forecasted to use more electricity by 2030 than all 6.8 million residents of the state using their homes today. In Ireland, data centers already consume 21% of the entire country's electricity. Because the grid wasn't built for this, utility companies are scrambling. They are planning to build new natural gas plants or even keep old, dirty coal plants running longer just to feed the data centers. This means more air and climate pollution, more carbon dioxide, and more methane. You might wonder why more people aren't talking about this. Part of the reason is that these projects are often shrouded in secrecy. Large tech companies frequently use shell companies and secret code names like Project Skyway or Project Jupiter to hide their identity. They often force local government officials to sign non-disclosure agreements. This means the public doesn't find out how much water or power a facility will use until after the deals are already signed. A leaked internal memo from one major tech giant revealed that they intentionally hid secondary water use, the water used by power plants to generate the electricity they need, because they were afraid it would hurt their reputation. They knew the real numbers would look much worse than what they were telling the public. Let's talk about some of the common myths the industry uses to justify this growth. Myth 1, they create thousands of jobs. Reality, while they create construction jobs for a short time, once they're built, they need very few permanent staff. In Indiana, one utility disclosed that AI data centers only create about 0.26 jobs for every megawatt of power they use. Other industries usually create 41 jobs for that same amount of power. These are warehouses for machines, not people. Myth 2. Dry cooling is the perfect solution. To save water, some centers use air to cool their servers, but air isn't as efficient as water. These dry systems use significantly more electricity, up to 25% more in some cases. It's a trade-off. You either use a massive amount of water or an even massiver amount of power. Myth 3. They are water positive. Reality, many tech companies pledge to be water positive by 2030, meaning they return more water than they use. But they often do this through offsets, like funding a project to fix leaky pipes in a different part of the state, or even a different watershed. This doesn't help the local community whose specific aquifer is being drained today. Who pays for all of this? Often it's you. Building the new transmission lines, substations, and power plants to serve these giants costs billions of dollars. In Virginia, it's estimated that residential electric bills could more than double by 2039 to pay for the data center infrastructure. In some areas, residents have already seen their bills jump by over 200% compared to 5 years ago. There is also noise pollution. Beyond the invisible demand for water and electricity, data centers impose a very physical, sensory toll on the people living near them: noise and air pollution. While a single computer server might be quiet, thousands of them packed together generate incredible heat, requiring massive industrial cooling fans and HVAC systems that run 24/7. Neighbors in states like Virginia and Arizona describe a constant electronic hum that never stops. Some residents have measured this noise at 65 decibels throughout the night, which is roughly as loud as a car passing by your window every second of the day. This isn't just an annoyance. Research shows that people living with this level of constant noise experience an increased risk of hypertension and heart attacks. Because much of this is low-frequency noise, the human brain has a hard time filtering it out, leading to sleep disturbances, migraines, and chronic stress. These sounds are notoriously difficult to silence, often traveling up to 2.5 miles and passing right through traditional sound barriers or rows of trees. Then there is the air quality. To ensure AI systems never go offline during a power failure, data centers are equipped with rows of industrial-scale backup diesel generators. A single plant facility in Indiana, for example, is set to have 36 diesel generators, each with a 6,000-gallon fuel tank. These engines aren't just for emergencies. They're tested for 50 to 150 hours every year to ensure they stay functional. This routine testing releases staggering amounts of nitrogen oxides and particulate matter, the kind of soot that can cause respiratory disease, cardiovascular issues, and even cancer. In areas already struggling with smog like Houston or Dallas, a cluster of data centers can release hundreds of tons of these pollutants annually. The pollution also happens far away at the power plant. Because AI centers use so much electricity, utility companies are under pressure to keep expensive and dirty coal plants open longer than planned just to meet the demand. This creates more coal ash, which can leach into groundwater and cost millions to clean up. Even the construction of these giant warehouses takes a toll, as heavy diesel machinery and the manufacturing of thousands of tons of concrete and steel release massive amounts of carbon dioxide and dust into the local environment before the facility even opens its doors. Is there a better way? Yes, and some companies are starting to use it, often because they're being forced to by new laws. Instead of evaporating water into the air, some new systems use closed-loop liquid cooling. This is like the cooling system in your car. The liquid stays in the system and is reused over and over. Some data centers are starting to use treated wastewater or gray water for cooling instead of using clean drinking quality water. In Ireland and Denmark, some data centers are being hooked up to city heating systems. The waste heat from the computers is piped into people's homes to provide warmth in the winter. In Europe, new laws now require data centers to report exactly how much water and power they use. In the US, states like Indiana and New York are starting to demand that data center companies pay their fair share of infrastructure costs, so the burden doesn't fall on regular families. We're heading toward a major crossroads. Experts predict that by 2028, we will hit a crisis point where the demand for water from AI will collide with a massive national water deficit. In the UK alone, there's a projected deficit of 5 billion liters of water per day by 2050, and current plans don't even account for the growth of AI. Across the world, people are starting to push back. In 2025, the number of data center projects canceled or blocked by local residents quadrupled. People from both sides of the political aisle are calling for moratoriums, pauses on all new data center construction until we can figure out how to do this sustainably. Artificial intelligence has the potential to solve some of our biggest problems. But we have to be honest about what it costs. We can't build a digital future if we destroy our physical foundation of water and power to do it. The next time you hear about the cloud, remember it's a massive industrial system that lives in your backyard, drinks from your pipes, and draws from your grid. The true test of our intelligence as a society won't be how fast our chatbots can talk, but whether we can manage our finite resources wisely enough to have a future at all. Thank you for watching. Don't forget to like and subscribe to stay informed on the stories that shape our world.